NASA said impossible. SpaceX just shocked them with metal shields surviving 500 degrees Mars re-entries, while NASA's ceramics shatter after one use. The insane part? Musk secretly designed these as Mars apartment buildings. But wait, how does metal not melt when everything else does? What's the hidden tech NASA missed? Let's dive right in. Picture this, 2019 SpaceX headquarters. NASA's top heat shield engineer just finished reviewing Musk's proposal. His words, "This is engineering suicide. The plan? Replace proven ceramic tiles with raw stainless steel. The stakes? Human lives on Mars." That engineer wasn't wrong to be scared. Every spacecraft in history used ceramics for re-entry. The Space Shuttle's 24,000 tiles? Ceramic. Apollo's heat shield? Ceramic. Even SpaceX's own Dragon capsule? Ceramic. But here's what NASA didn't see coming. Musk wasn't just building a heat shield, he was building humanity's first Martian cities. Let me tell you what NASA discovered about Mars that terrified them. Earth's re-entry? It's like getting punched in the face. Brutal but quick. 115 over 100 degrees Celsius for maybe 10 minutes, then you're done. Your ceramic tiles handle that violent but brief encounter. Mars re-entry? It's psychological torture for spacecraft. You're not getting punched. You're being slowly cooked alive. The thin Martian atmosphere means you don't get that quick, brutal heating. Instead, you get sustained heat buildup across your entire hull for what feels like forever. But here's the killer detail that made NASA engineers lose sleep. Mars's atmosphere is 95% carbon dioxide, and CO2 becomes aggressively corrosive at high temperatures. It literally eats ceramic and composite materials from the outside in. Picture this scenario. You're 140 million miles from Earth. Your ceramic tiles start dissolving in Mars' acidic atmosphere, and there's no rescue mission coming. NASA knew ceramic was a death sentence for Mars missions. When Musk announced that Starship would use stainless steel instead of 200 per kilogram carbon fiber, the aerospace industry erupted in laughter. Stainless steel costs $3 per kilogram. In aerospace, cheap means dangerous, right? Wrong. Musk had done something no one expected. He grabbed a massive steel plate and aimed industrial flamethrowers at it. Temperature, 100 degrees. Hot enough to melt copper. NASA's ceramic tiles would have exploded into fragments. The steel barely flinched. But wait, steel melts at 1,500 degrees, and Mars re-entry hits exactly that temperature. So how does steel survive what should kill it? This is where Musk's team broke the laws of physics as we knew them. Here's where it gets absolutely insane. SpaceX didn't just use metal heat shields. They made them sweat. Literally. Think about how your body cools itself. When you overheat, you sweat. The evaporation steals heat from your skin. SpaceX copied this biological process and scaled it up to spacecraft size. They created a stainless steel sandwich, 2 layers of steel with coolant pumping between them. But here's the genius part that shocked NASA. The outer layer has thousands of tiny holes. During re-entry, coolant seeps through these holes and evaporates, stealing massive amounts of heat. The hotter the re-entry gets, the more the ship sweats, the cooler it stays. It's self-regulating. NASA engineers called it impossible because they'd never seen active cooling work during the chaos of re-entry. But the real breakthrough? The coolant. Instead of carrying extra water, SpaceX uses methane, Starship's own fuel. Why pack extra cooling liquid when your fuel tank doubles as your cooling system? NASA's ceramic tiles were handcrafted artisan products, each one individually fitted, individually inspected, individually replaced after every flight. 18,500 failure points per mission. Then they saw SpaceX's test data. These metal shields weren't just surviving multiple re-entries, they were getting stronger. Each flight proved the system instead of destroying it. Picture NASA's reaction. While they spent months replacing thousands of tiles after every shuttle flight, SpaceX just refilled coolant tanks and flew again. It was like watching someone change a car's oil while everyone else rebuilt the entire engine. The data was undeniable. SpaceX had solved the impossible problem. True reusability. But NASA was about to discover this wasn't just about landing on Mars. It was about living there. Here's the twist that changed everything. Musk's recent revelation that these heat shields aren't just for spacecraft. They're prefabricated Martian apartments. Think about this insanity. The same metal shell that just survived 1,500 kilometers re-entry is now protecting colonists from radiation that's 100 times stronger than Earth's. Mars bombards everything with deadly cosmic rays. Traditional habitats need thick concrete bunkers or underground shelters. But Starship's hull, reinforced by those same metal heat shields, becomes an instant radiation-proof building. Each landed ship is a 50-meter-tall, 9-meter-wide pressure-sealed cylinder ready for human habitation. The heat shield panels are modular. Need to connect two ships? Remove panels and weld them together. Need to expand your habitat? 3D print new shield sections using Martian metals. The system is designed for a planet where calling Earth for spare parts isn't an option. But here's what NASA won't say publicly. This is the biggest engineering gamble in human history. You're asking people to live inside what was essentially a fuel tank that just survived temperatures hot enough to melt copper. Every weld becomes life-critical. One failure in your heat shield-turned wall, an explosive decompression kills everyone inside in seconds. The pressure differential between Mars' thin atmosphere and your breathable interior is massive. What happens when Martian dust storms last for months, slowly abrading your heat shield exterior? What happens when thermal cycling between Mars' 100-degree nights and plus 120 days causes metal fatigue? What happens when that corrosive CO2 atmosphere finds a weak point? NASA spent decades learning these failure modes the hard way. SpaceX is compressing that learning curve into a few test flights and hoping they don't miss anything critical. Here's what most people don't understand about SpaceX's breakthrough. It's not just the sweating system, it's the metallurgy revolution happening inside those heat shields. SpaceX employees are secretly some of the world's most advanced metallurgists. They've developed exotic alloys with names like SX500, materials that didn't exist 5 years ago. These aren't just heat shields, they're next-generation materials engineered at the atomic level. But even these exotic metals would melt under Mars re-entry conditions. So SpaceX added another impossible layer, film cooling. They pump small amounts of cool methane along the shield edges, creating thin protective layers of cooler propellant that act as thermal barriers. The result? A heat shield that actively fights temperature rise through 3 different mechanisms: evaporative cooling, advanced metallurgy, and film barriers. It's like having 3 different insurance policies against thermal death. Here's another angle that terrifies traditional aerospace. Production scale. NASA's ceramic tiles were handcrafted by artisans, each one unique, each one requiring individual attention. You can't mass-produce artisan tiles. SpaceX's metal heat shields? They're welded by robots, mass-produced on assembly lines, and standardized across entire fleets. When you need to build hundreds of starships for Mars colonization, artisan craftsmanship becomes the bottleneck. But scaling up brings terrifying new risks. When you're producing heat shields on assembly lines instead of crafting them individually, how do you maintain quality control? How do you ensure that shield number 10,000 performs as well as shield number 1? One bad batch of shields could kill hundreds of colonists. The quality control requirements are insane, but SpaceX is betting their automated manufacturing is more reliable than human craftsmen. Here's what Musk hasn't fully revealed. These heat shields are designed as complete life support building blocks. Each panel contains integrated channels for running power, water, and data lines between connected ships. Remove a few heat shield panels, and you've got instant airlock connections between habitats. The same cooling channels that saved you during re-entry now become your environmental control system on Mars. But here's the scary part. You're living inside a system designed for the violence of spaceflight. Your bedroom walls are the same materials that just endured re-entry plasma. Your kitchen is inside what was a propellant tank. Your life depends on welds that were stressed by forces that would crush a building. What keeps NASA awake at night? The failure modes they haven't tested yet? What happens when a micrometeorite punches through your heat shield during the Mars transit? What happens when a hard landing creates microscopic cracks that slowly grow under pressure cycling? On Earth, you can land and inspect every inch of your heat shield. On Mars, you get one chance to land safely, and then that same shield becomes your house. There's no backup plan, no rescue mission, no way to evacuate if something goes wrong. NASA's approach would be to test everything exhaustively, run thousands of simulations, and have backup systems for the backup systems. SpaceX's approach is to iterate rapidly, fail fast, and learn from real-world testing. Both philosophies have merit, but only one is betting human lives on largely untested technology. The most shocking thing about SpaceX's success? They're operating at the absolute limits of what's physically possible. That 300 bar chamber pressure in Raptor engines, that's approaching the theoretical maximum for hydrocarbon fuels. Those heat shield temperatures? They're dancing on the edge of steel's melting point. There's almost no margin for error. Everything has to work perfectly every time, or people die. NASA builds in massive safety margins. SpaceX operates at the bleeding edge and relies on precision rather than over-engineering. This fundamental difference in philosophy explains why NASA thinks SpaceX is crazy and why SpaceX thinks NASA is too conservative. Both might be right. Here's what Musk isn't saying publicly. This entire system depends on one critical assumption, that they can manufacture and maintain these exotic materials and complex cooling systems on Mars using only local resources. If that assumption is wrong, the entire Mars colony concept collapses. You can't ship replacement heat shields from Earth every time something breaks. You can't rely on Earth-based manufacturing for critical life support components. SpaceX is betting everything on their ability to recreate advanced Earth manufacturing on a planet with no infrastructure, no skilled technicians, and no backup plans. It's the ultimate test of their best part is no part philosophy. The metal heat shields aren't just solving the landing problem. They're the foundation of human civilization on Mars. If they work, we become a multiplanetary species. If they fail, a lot of people die very far from home. So here we are. NASA called it impossible, but SpaceX just turned metal heat shields into humanity's ticket to Mars. We've seen the breakthrough, the risks, and the revolutionary engineering that makes it all possible. But this isn't just about landing on Mars anymore. These heat shields represent something bigger, the difference between playing it safe and betting everything on an impossible dream. NASA's approach: test everything 1,000 times, build massive safety margins, and never risk human lives on unproven technology. SpaceX's approach: iterate rapidly, embrace controlled risk, and push the absolute limits of physics. Both philosophies have gotten us to space, but only one is promising to make us a multiplanetary species. The real question isn't whether these metal heat shields will work, it's whether we're ready to trust our survival to technology that breaks every rule we thought we knew about spaceflight. What do you think? Are we witnessing the birth of interplanetary civilization or the most dangerous gamble in human history? Let me know in the comments, because this conversation is just getting started. And if you want to see how SpaceX's Raptor engines are pushing the same impossible boundaries, check out our deep dive on why they're years ahead of anything NASA has ever built. Trust me, you won't believe what they're doing with methane and metallurgy. Thanks for joining us on Space Core, where we don't just watch the future, we decode it. After that explosion destroyed everything, Ship 37 wasn't supposed to work again. Ever. But in just 48 hours, SpaceX did something no one saw coming. They mounted it directly on the orbital launch mount and fired all 6 engines for 10 seconds. The shocking part? This impossible test just revealed SpaceX's secret weapon for Flight 10. But what happened next will blow your mind. Let's dive right in. Here's the brutal truth about that June explosion. It should have killed Starship forever. When Ship 36 detonated, it didn't just destroy one vehicle. It obliterated SpaceX's entire testing philosophy. The Massey facility was gone. The methane tank farm, vaporized. The static fire stand? History. But instead of taking months to rebuild like any sane rocket company would do, SpaceX did something that defied every rule of aerospace engineering. They threw out the playbook entirely. Within 48 hours, SpaceX made a decision that sent shockwaves through the industry. They would mount Ship 37 directly onto the orbital launch mount, a structure designed for full rocket stacks, not individual ship testing. This was like trying to service a motorcycle in a Formula One pit stop. But here's where it gets absolutely mind-blowing. They had to completely hack their own infrastructure to make it work. Picture this: SpaceX engineers ripping out all 20 booster hold-down clamps and replacing them with custom adapter plates. They hijacked the booster quick disconnect system, a mechanism built to fuel a super heavy booster, and forced it to feed propellant to a Starship sitting where it was never supposed to be. This wasn't just improvisation. This was SpaceX betting everything on a completely untested approach. One miscalculation could have destroyed both Ship 37 and their primary launch infrastructure. Why take such an insane risk? The answer will shock you. That first static fire on Thursday wasn't just any engine test. It was a single Raptor firing for 6 seconds using only header tank propellant. And it proved something that could make or break humanity's future on Mars. This test simulates the most critical moment in any interplanetary mission, the deorbit burn. When Starship returns from Mars, it gets one chance to reignite its engines in the vacuum of space using whatever fuel remains in those tiny header tanks. Previous attempts? Let's just say they had mixed results. But Ship 37's test proved the impossible. SpaceX has cracked the code. The engine startup sequence is now bulletproof. The propellant flow is stable. The ignition timing is flawless. But that was just the appetizer. Friday's test was the main event. 6 Raptor engines, 10 seconds of sustained fury, all systems green. Those 10 seconds generated enough thrust to lift 200 tons, equivalent to 8 Boeing 747s pushing straight up while being held down by the test stand. The structural loads were astronomical, and everything held. Everything. But here's the part that will blow your mind. This wasn't just about proving the engines work. This was about proving SpaceX's rapid iteration philosophy works at scale